Let's say there are two communities, an orange community and a purple community, and they're separate from each other. And your job is to go into these communities and find out what the most common influenza type is that's circulating among the people. So you do this, and the first thing you discover is something that's pretty interesting, which is that in the orange community, turns out that they really only have influenza type A. Remember that there are 3 types of influenza, and over here, the only one that seems to be affecting people is type A. So let me actually write that over here, type A. And if you go over to the purple community, you actually find quite the opposite. You find that over here, people are also getting the flu, but it's always because of type B. So these people over here are having influenza type B. And influenza type B also has 8 strands of RNA. And let me write in purple then type B. So that's what you learn in the first kind of day on the job. Now there are many different types of type A that are affecting the orange community. And what I've drawn for you is just the dominant strain. The dominant strain. So there may be a handful of type A's affecting the orange people, but this is the dominant strain. And you know, actually the same is true over here in the purple community. They have a few different type B's circulating, but the dominant strain is the one that I've drawn for you. So now let me make a little bit of space and let me tell you what you're going to have to do. Over the course of the next year, over the course of the next 12 months, you're going to actually have to follow these two communities. And what you're going to do is basically track out over that year what's happening with the dominant strain. So that's what we care about. Not all the strains, but just the dominant strain. And you want to know how genetically different is it compared to what it was like on day 1 of your job. So when I say genetic change, I'm really comparing it to what it was like on the first day of your job. Comparing to initial strain. So over the 12 months, you'll get a real good idea of how much change happened while you're on the job. So let's say you start out and you live close to the purple people. So of course initially there's no change, right? You're doing the type B strain and you're saying, well, yep, it hasn't changed yet. But some time passes. Let's say you spend some time away and you come back and you visit the purple community and you ask them, hey, what is the common type B strain that you guys are seeing nowadays? And they say, well, it's basically the same as it used to be. It hasn't really changed a lot, but there are 2 point mutations that have happened. So the dominant strain now has a couple of point mutations, so it's a little bit different than it used to be. And you say, aha, there is some genetic change happening here. The dominant strain is changing a little bit. And then you go and you kind of visit again sometime later, and they say, yep, thanks for visiting again. A couple more changes have happened since you last were here. And you say, interesting. Let's plot that a little bit higher. So now the virus, the type B virus, is looking slightly different from how it was when you first started the job. And you keep going with this process, and there's a mutation here, another one over here. Some mutations kind of pile up. And basically what you get is kind of a staggered line, something like this, where it kind of goes like that all the way to the end of the year. So the end of the year comes and you look back at your virus and you say, there are a few mutations. It's a little different than what it was like when I started. And those little mutations you can see with the yellow X's. So what would we call this process? We'd call it genetic drift. This is genetic drift. This is kind of the normal process that happens with many, many types of viruses and bacteria. Really, all viruses and bacteria make mistakes when they replicate. And so you're going to see some degree of genetic drift over time. So now here's the cool part. You go to the orange community, the orange county, if you want to call it that, and you say, hey, I'm here to do the exact same thing with your type A influenza virus. And well, in the beginning, of course, it's not any different. But you come back a little bit later and you notice that this one has had a couple of changes, a few mutations, just like you saw before. So you say, okay, well, so far so good. It looks like it's a little changed. And then you find out that, there's one more mutation when you come back on another trip. So you say, okay, looks like it's a little changed further. And then a really interesting thing happens. What you find out is on a third trip that this entire, segment is gone. and it's replaced by this. So you see a huge new chunk of RNA. So how do you plot that on your genetic change axis? Well, it's really different, isn't it? So you'd say, okay, well, gosh, now that 1/8 of the entire thing is different, that would be something like this. That's a huge jump. So you say, okay, well, now there's been a huge genetic change. And then you come back on another trip and you find out that there's a little mutation in this green RNA and maybe one over there. So again, you've got a little bit of change. And you go and you find out that there was another mutation here, maybe one over here. And so you keep plotting. You're very loyal to your job. You keep plotting. And then it turns out that there is another big shift. Let's say this piece gets changed out for this one. And so again, you have a big jump, right? Something like that. And finally, by the end of the year, it kind of goes up again because you've got a couple more mutations. So let's say there's another mutation there and there. So that's what it looks like, right? The genetic change over time for the orange one, the type A, is actually looking quite different. And this one actually has elements of what I would call genetic drift and shift. And more specifically, this part would be kind of a big shift, right? This is where a whole chunk of RNA got kind of incorporated into the dominant virus. These are two shifts that might have happened that year. And these other parts, let me circle with a different color. Let's say over here, this and this is actually looking more similar to what we talked about before. These are just kind of steady changes, steady mutations over time. And this is kind of what we have come to know as genetic drift. So with type A influenza, done in orange, you can see that there is some drift and some shift happening. And with type B influenza, there's only genetic drift. Now what happens, and this is kind of the scary part about type A influenza, is that whenever you have these giant shifts, there are two here, whenever you have these shifts, the entire community hasn't really experienced that new type A influenza. They're not used to it. Their immune systems don't know how to deal with it. And so many people can get sick. And what we call it is a pandemic. So in the past, we've had a few pandemics, and each time it's usually because of a big genetic shift that happens, and many people, as I said, get sick, go to the hospital, and can even die.